Calculate rock mass properties, your professional geotechnical analysis tool. Welcome to this tutorial of Rock Mass Properties Calculator, a powerful web-based tool designed specifically for geotechnical engineers, mining professionals, and civil engineers working with rock mechanics. This application uses the renowned Hoek and Brown failure criteria to calculate rock mass properties for tunnel design, underground excavations, and slope stability analysis. What this calculator determines. It will determine rock mass properties, C and phi values of rock mass, stresses and deformation in the tunnel crown and walls. The important factor we will determine will be the severity of squeezing and deformation in the tunnels due to in situ stresses, depth of tunnel, and the quality of rock. All these parameters we will find through this calculator. Here are the overview of the parameters and the formulas used in Hoek and Brown failure criteria, where you can see GSI chart, failure criteria formulas, and other formulas to determine rock mass properties. For more information, reference articles are provided on our last slide. Many geotechnical software tools use the Mohr Coulomb failure criteria, which means we often need to convert the Hoek and Brown rock mass properties into equivalent Mohr Coulomb friction angles and cohesive strengths. This calculator also helps in converting Hoek and Brown rock mass properties into equivalent Mohr Coulomb cohesion and friction angle. We can see in this slide the equivalent C and phi values of rock mass. The maximum tangential stresses surrounding the tunnel opening will be estimated using the correlations suggested by Hoek and Brown. The reference of the article is provided in the last slide. The parameters required for determining these tangential stresses are the vertical stresses and the stress ratio values. In the calculator, you will also calculate strains around the tunnel, which will be used to determine squeezing conditions in the tunnels. In the next slide, we will see how the parameters from the Hoek and Brown failure criteria are used to determine squeezing condition in excavated tunnels. In this slide, we will see how the rock mass parameters we determined in the previous slides are used to determine squeezing conditions in excavated tunnels. This slide demonstrates how rock mass strength relative to in situ stress predicts tunnel squeezing behavior. The first graph classifies squeezing severity from minor problems at strain below 1% to extreme squeezing above 10% based on the ratio of rock mass strength to in situ stress. The second graph validates this relationship using the empirical formula as shown in the second graph, where strain equals tunnel wall displacement divided by tunnel radius expressed as percentage. These graphs confirm that as rock mass strength decreases relative to stress, tunnel strain increases exponentially. Together, these figures enable engineers to predict squeezing severity and determine appropriate support requirements before excavation begins. We have included in the calculator the squeezing severity and strains in the tunnels. In the next slides, we will see how to use this calculator to generate the results. Today I will show you how to use both the single calculator for individual analysis and the batch calculator for processing multiple scenarios simultaneously. On the top right corner of the screen you can see there is a single calculator and batch calculator. Single calculator generates results only for single problem, whereas the batch calculator you can go up to 50 problems. In this video, we will see the input parameters required for calculating rock mass properties. On the left side of the panel, we need to incorporate all input values. As you can see on the slide, the input parameters are mentioned. The first is the intact rock, second is rock mass conditions, and the in situ stress conditions. In the intact rock properties, we need to provide uniaxial compressive strength of intact rock, material constant, and Young's modulus of intact rock. In rock mass conditions, we need to provide GSI values, disturbance factor, and reduction factor for rock mass modulus. In situ stress conditions, we have to provide the lateral stress ratio, tunnel depth below the surface, which is used to calculate vertical stress, and the unit weight of the overburden. The input tunnel dimensions, we have to provide tunnel diameter or equivalent diameter. In this slide, we will see the output results. Once you input all parameters, the calculator instantly displays the results, which are consist of stress analysis, Hoek and Brown parameters of rock mass strength, rock mass deformation properties, stability indicators like the intensity of squeezing, and failure envelope chart. As we can see in this video, we can see the failure envelope chart showing the minor and major principal stresses on the curves. And as we go down, we can see Hoek and Brown failure criteria and equivalent Mohr Coulomb equation. As we go more down in the video, we can see the calculated results. We can also find download PDF from which we can download input and output parameters of the rock mass. We go down in the calculator, we can see Hoek and Brown parameters, failure criteria, curve. In situ stresses consist of vertical and horizontal stresses in the rock mass strength parameters, strain analysis. We can also find C5 values determined for Mohr Coulomb failure criteria. In this slide, I will talk about the batch calculator. The batch calculator ideal for parametric studies where there is a varying GSI values, different depth of tunnel, or other parameters. We can also use if the tunnel section is different along the alignment of the tunnel, and it can also be used for comprehensive analysis between different design alternatives. For that, we need to click batch calculator, where we can extend the problems up to 50 rows. In the batch calculator, the method of entering is the manual entry, or we can also import Excel file or CVS file. Now here we will go and click batch calculator, and here we can see there are few rows. There is a row, and I have added one more row where I have increased the depth to 100 meters, and then GSI up to 40. I've reduced the GSI value and UCS value to make the rock quality around the tunnel very poor, and increase the K value to 2. It means the in situ stresses are also high at this location of tunnel. As we go towards right, we can see there are 2 rows of output results. Now once we will go there and we click calculate all, it will give the results of all the rows together, and then we can go further and see the severity of squeezing in the tunnel due to different input parameters in both the rows. Now once the things we have done here, and we go back to home on the top right corner, we are here to see the reference chart, where we can see the different squeezing conditions in the chart, which is between strain and squeezing ground conditions. As we go down and see this graph, here we can see there is a graph between strain and rock mass strength by in situ stress, and in the calculator we have seen that in the first row the strain value is less than 1, so it is showing few supports problem, and in the second problem is showing that the strain value is between 2.5 and 5%, so it is showing severe squeezing condition. So in this way we can input different problems in batch calculator and find out different strain values, and accordingly we can consider different squeezing conditions in the rock. So now we go back to our batch calculator. Now we can see here if the already filled input parameter row, and we calculate it here, and we can see here that our strain value is less than 1 and it is showing few supports problem. Similarly, we can change the input values for different problems, and we can find their different rock mass properties, strain values, deformation in the tunnels, and the severity of squeezing a rock in those tunnels. Slide, we will see who can use this calculator. This calculator can be used by geotechnical engineers, mining engineers, engineering geologists, and graduate students and researchers. For geotechnical engineers, they can use it for preliminary tunnel design and feasibility studies, support system design and optimization, risk assessment for underground excavation. Mining engineers can use for underground mining design, shafts, drifts, stopes, pillar stability analysis, ground support requirements. Engineering geologists can use it for rock mass characterization, site investigation planning, and geological model validation. And for graduate students and researchers, they can use this calculator for learning Hoek and Brown failure criteria applications, academic projects and thesis work, comparative studies with other methods. In this slide, the reference articles have been provided on which this calculator is based. It is recommended to read these articles for better understanding of the basics of the rock mechanics and using this calculator. Soon I will provide tutorial of using calculator for different scenarios. Please write to me if you need more details.